Welcome back to video 1 of Unit 8. So today our goal, given an absolute value function, you will be able to, with the help of your calculator, find points of the function and graph. Okay, for today's lesson you definitely need your graphing calculator and something to draw straight lines with. All right, so let's go back to this idea of absolute value. Now, absolute value is something that we talked about way back in 6th grade. Okay, so the absolute value is the distance from 0. So for instance, the absolute value of -5, well, -5 is 5 units from 0, so its absolute value is 5. Another example would be negative and then absolute value of 5. Well, 5 is 5 units from 0, and then you negate it, so this is the only time you get a -5, is if there is a negative on the outside. Now, what we're going to do now that we're in algebra is we're going to talk about absolute value as a function. Because every time you put a number inside of the absolute value symbol, are you getting an output? Yes. Okay, so that means that this is indeed a function. So we could write y is equal to the absolute value of x. Okay, that would be our absolute value function, or we can put it in function form. F of x is equal to the absolute value of x. Okay, so now to use our calculators to find absolute value. So on your calculator, so you're going to want to follow these directions. I like using this direction right here in our little table there. So to find the absolute value of something, so let's go back and let's try to find that absolute value of -5. So we're going to hit the second button, and now the catalog button is above the 0, so we hit the 0. Now catalog, this is every single command that you can find on all of these buttons on the calculator. But if you look, absolute value is the first one, so we hit enter. Okay, and now I have my absolute value symbols. Now, if you have an older version of the calculator, you might have the letters ABS and then parentheses. So you want to make sure you end your parentheses for that one. So we're going to type in -5, and then I can use my over arrows to go outside. I hit enter. The absolute value is 5. Okay, so if we want to graph absolute values, so let's go down here. So graphing absolute values, so we're going to take just our regular function, y equals absolute value of x. We're going to call this the parent function. All right, and we're going to plug it in. So we're going to go y equals, clear everything out. So if it's second catalog, absolute value is the first one. So since my little triangle is next to the ABS, I can just hit enter. And now I type in an x, and I go outside of the parentheses. Now let's see what this looks like. So everybody go ahead and hit your graph button. Okay, remember, if for some reason we haven't used the graphing calculators in a while, let's say your window, you kind of had a weird window going on and you couldn't see that, you're going to hit zoom, and then you're going to go down here to standard, which is choice 6, and it'll bring you back to your 10 by 10 grid. So if we take a look at our function here, it looks like what shape? It looks like a V. All right, well, let's think about this. Why did our function not go below the x-axis? Well, remember, if we're talking about up here, can you ever get a negative absolute value symbol? No, absolute value is always going to be positive, which means it's always going to be above that x-axis. Okay, so now our goal for today is to find points and be able to graph them. So we have to first off look and see, well, where's the middle of your V? The middle of our V looks like it's the point 0, 0. So I'm going to go to my table of values, and I'm going to put 0 for my middle x. And this is just an estimation. Now I'm going to hit second table of values, because this is where I can find all of my points. All right, and I'm going to go ahead, and I want to make sure I have points on both of the two sides of that V. So I'm going to try to put 0 kind of in the middle there. And now I can see that this is actually going to have some symmetry to it. So I'm going to start at -1, -2, oops, that's going to be -3, and -4. And then 1, 2, 3, 4. Oh, I plotted. My table's got a lot of points there. Okay, so let's take a look then. So if my value is -4, my y value is 4. -3, we have 3, 2, 1, 0, and now we're going to go back up. It looks like we're going back up into the positives. 1, 2, 3, 4, and 5. So we have our table of values, and now we can go ahead and graph this. So I'm going to start at -4, 4. Okay, and then we're going to go a nice little diagonal here. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And hit graph. Now remember, these go on forever. This is a function, it goes on forever. So we want to make sure that we draw it with our arrows at each end point. And then I can go to one of the arrows and I'm actually going to label it the absolute value of x. Okay, so now we found our points, we've graphed it, so let's answer some follow-up questions here. So number 1, is the graph a function? Well, let's take a look. Does it pass the vertical line test? Yes, it does. It passes the vertical line test, so yes, it is a function. So what is the domain? Remember, your domain, those are your x values. Okay, well, if I take a look at my domain, domain is your x's, so left to right. So are these two arrows forever going to be going to the left and to the right? Well, yes, they are. So your domain is -infinity is less than x, which is less than +infinity. So your x is all real numbers. Now let's take a look at your range. Your range is your y's. Now if we look at our y values, our arrows go up. So that means, does our y value go up to +infinity? Yes. Now do we have any arrows pointing down? No. So we do not go to -infinity. So what's the lowest y value on the point? Well, our lowest y value, so here we're going down, 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 down. It's right here. So our lowest point is 0. So 0 is less than or equal to x, which is less than infinity. So our range goes from 0 all the way to infinity. All right, what is the y-intercept? So y-intercept's where it crosses the y-axis. It crosses the y-axis right here, so our y-intercept is 0, 0. And are there any roots, your x-intercept? Well, your x-intercept, it touches the x-axis right here. It's the same as the y. And now we've got it. All right, let's take a look at another example. So let's go down now to number 2. So on the set of axes below, graph the function from -2 to 4. So here, they're telling us, remember your x is your domain. They're telling us that we only want to graph this function from -2 to 4. So this actually makes it a little bit easier for us. So we're only going to graph from -2 all the way to 4. So that's where we're going to put our x's in the table. So now we have to find the y values that go with it. So I'm once again going to go my y equals, clear it out. Then I have to type in the absolute value of x minus 2. Second, catalog, absolute value, x minus 2, and then I go over plus 3. And then I'm going to find my values. So -2 is 7, -1 is 6, 5, 4, 2, looks like it's 3, 3 is 4, and the value 4 is 5. So now I'm going to go ahead and I'm going to plot these points. So -2 and 7, -1 and 6, 0 and 5, 1 and 4, 2 and 3, 3 and 4, so now we're going back up. Now, when we connect these, because it told us we're only going from -2 to 4, you cannot draw arrows. So all you're going to do is connect your dots, but that is it. You're going to end at that end dot. So right there to right there. So let's answer our follow-up questions. Is this graph a function? Well, yes, it passes the vertical line test. What is the domain? Well, the domain, your first x value starts at -2 and it ends at 4. So your domain is -2 is less than or equal to x, less than or equal to 4, just like they wrote up there. Next up, what is the range? So your range is your biggest y value and your lowest y value. So let's start with your lowest. So what's the lowest y value? You can look at your table of values or you can look at your graph. So my lowest y value is right here, which is 3. Which is less than or equal to y, which is less than or equal to, what's your highest y value? right there, and that is 7. Do you have a y-intercept? So does it cross the y-axis? Yes, it does, right here at 0, 5. And does it have an x-intercept? No, it never touches the x-axis, so we've got it. So ladies and gentlemen, this is how we find our points and we plot our graph. You're going to use your graphing calculator each time. So let's go ahead and flip over the page and let's take a look at what we can do with our absolute value functions. So here we have y equals the absolute value of x. So I'm going to call this the mother function. It's the most basic of our functions because there's an x there and we're not doing anything to that absolute value of x. So we have that right here. So I graphed that for you already. So we're now going to compare what happens when we make modifications to that function. So let's take a look at number 1. Below is the graph of y equals absolute value of x plus 2. What effect did adding 2 to the absolute value have on the graph? So everybody take a look at your new graph. This is the graph y equals absolute value of x plus 2. Now look at your mother function. What changed? What happened when we added 2? Well, what I noticed is that it looks like the vertex went up 2 points. So I'm going to write that it translated 2 units up. Or translated, sometimes we like to use the word it shifted. You could say it shifted, or you could just say it moved 2 units up. All right, so let's take a look now at the second one. Below is the graph y equals absolute value of x minus 2. What effect did subtracting 2 to the x inside of the absolute value have on the graph? So here we subtracted 2, but it was inside of the absolute value. So look what happens from your mother function to your new function. So what happened? Well, this time it looks like the whole graph shifted 2 units to the right. So here I'm going to write it shifted 2 units to the right. Did it change the v? Nope, the v is still there. It's just moving its location. Let's take a look at number 3 then. Below is the graph of y equals negative absolute value of x. So what effect did multiplying the absolute value by -1 have on the graph? Well, our mother function was up here. Now we're down here. So what do we call that when it goes down? Well, that's going to be a reflection over the x-axis. So here we're going to write it reflected over the x-axis. All right, and now let's take a look at our last one. So below is the graph y equals 3 times the absolute value of x. What effect did multiplying the absolute value by 3 have on the graph? Well, if we take a look at our mother function, here's the absolute value of x. All right, and then here is 3 times the absolute value of x. So if you look carefully, this one, a lot of people like to say, well, it's skinnier, so it's narrower. So you could say that it's narrower, but what does that mean if it's narrower? Well, it means it's growing at a faster rate of change, growing at faster rate of change. All right, ladies and gentlemen, great job today learning about graphing your absolute value functions. Next up, you're going to go ahead and try one of these on your own. So make sure that you finish your video on handout and have it ready to go for class tomorrow.